Hi guys, welcome to another C++ tutorial video. In this video, we will talking about basically user-defined data types. So let's create a file. We will call this user-data.cpp, and we can start learning about user-defined data types. First, let's just create a boilerplate code. So include, let's say, cstdio, and then int main. And the way we have seen so far is that we can define one variable at a time. For example, int a, b, and then let's say character c, or so on, or like multiple variables of the same type. For example, I can say an int array of that holds 10 elements and so on, right? But what about like user wants something different? You need something different, something that keeps collection of multiple amounts of data that are consistent of that consists of these primitive data types. So that's where structs come into picture. You just simply define a struct. Like in this case, I will be defining a complex number, so I will call it complex, and it has two parts. One is a float that is real, and one is a float called the imaginary, or img in short. Okay, so this is how you typically define a struct in C++. If you're using C, then you will probably, and you can just if you're using C, you will say struct complex C1 struct, and then you can assign the particular properties of that struct by accessing them through dot operator. In C++, although you don't need to like specify struct every time, you just define it once and you can just use it. The complex C1, for example, C1.real and C1.imaginary is equals to this. And now, if I want to look at the size of the struct, so I can say printf size, which will be equals to like size of C1. It's same as writing that size of complex. It will give us the size of the data that we are working with, and also like you need to put a semicolon here, and you can write multiple things, multiple data types here, and all of them will be packed in the memory. Accordingly, it's stored. Like we can say that character, for example, name, and we can have 10 characters for the name, right? And then we can, like for an example, I'm just giving you. You can also have like for example, let's say we have bull is good, and it might be true and false. So if we look into this, this float will take 4 byte. This float will take 4 byte. This character will take 10 bytes. All one character each will take 1 byte. So this string consisting of 10 characters will take 10 bytes, and this will take 1 byte. So 4 plus 4 plus 10 plus 1 is 19. So this will be of 19, right? So what I can do is I can just compile this by calling cl user data.cpp, and you get a bunch of errors like always. And it's saying what? Yeah, we need to put a comma here, and also like we need to put the placeholder. So this will work fine. Now if we compile this, it compiles successfully, and then we can just call this function user data, this application. And as you can see, it's of size 20. So why it's of size 20? The reason being that I am bad at maths. That one of the reasons. And because this particular struct has uh, for example, this name. Okay, if I just print the size of name, you will understand. Print like size of name percentile d, and like if I try to get the size of name, it should probably demystify the thing, and we get a lot of errors like usual, because print is not the function. The function is printf, right? So if we compile this now, we get some other errors, and that's where you would probably like to use something that has some syntax highlighting. We'll get to that, but we're doing simple stuff, so it doesn't bother that much. in this case, I guess. So now if we try to compile this, it compiles, and then we can say that dot slash user data dot exe. And as you can see, the name has size 10, the struct has size 20. So the reason I can give you, it's not that complicated. It's because of packing. Okay, but forget about that for now. What I want to and what I want to tell you is that like if I kept it like this, okay, it would and also like remove this, it would have size of 8. Okay, because the data is contiguous, but you can have different types in that data. So now if I compile this, and if I run this, you can see that it has size of 8, right? So sometimes like what you do, it seems like magic and something is going on that doesn't make sense. But like when you delve deep dive into it, and when you like dive deep into it, you will understand that like everything makes sense. And what happened here is that the compiler, it thought that like keeping 19 size is not good for like accessing the data. So it just added 1 byte of extra padding to this struct. Okay, you can just ask to have that struct as compact. We will look into that into later. But now that now what we are interested in just understanding that what kind of data we can have. So we have this struct here called complex, and this is how you typically define a struct. You can take an array of complex numbers like this, like just as you can use this complex as your new variable type. Okay, like you can say complex my complex array which has like 10 elements. Okay, and like for let's say int I equals to 0, I is less than 10, I plus plus. uh, my complex array is a real number is I, and my complex number array is imaginary number is I. This is how we can like assign them, and then we can just say that for int I is equals to 0, I is less than 10, I plus plus. We can say that printf my complex array I's real value is this, uh, I, it has the real value as this, and like let's do it the good way. So like percentile f and percentile fi, for example. Okay, like that's how we define complex number. If you have any experience with like the thing, but the complex numbers themselves. This is not a video about complex numbers, but I thought that it would be a good example of dealing with structs, so I picked this up. So as you can see, so this is how you typically access the values of a struct by using this dot operator, right? So if I compile this and we clear the screen and we run this user data, you can see that I forgot to put the like end line. So I just quickly uh, make an end line here, but you get the point that what I tried to get, and also like point two. I don't want to see all the floating point numbers. So if I compile this and we run this, you can see that it's 0 0 I 0 and so on. So this is how you can define your own data and take an array of it, and now you're like about storing the data and using the data. Your potentials are now limitless in C and C++. Now a good way to make a struct both C and C++ compatible is that using a keyword called typedef. You can say that typedef struct complex, and then we can put an underscore here, and then we can say complex. So this is how you can define a struct that will work for both C and C++. I can show you here that it has no difference. I can compile this. It compiles the same way. I can execute it. It gives the same output. So what typedef does is typedef allows you to like define something in a way. like with another keyword, just to use a word instead of another. For example, let's say I have an int, okay, and every time I want to use an int, I can call int a, right? But if I don't want to use this word int, what I can do is I can say that type def int as, let's say, daddy, okay, and now I can say like daddy a equals to 10, printf this, and it will work the same way, right? So you get 10. So that's what type def is. It's another keyword that's present in C and C++ that helps you to do that, right? Now, that's for structs, right? And another thing that you can do, like in C++, although you don't need like all these type def, these things, you can just simply define it like this, and it will be good as long as you don't forget the semicolon at the end. Okay. Now, another thing that you can do is you can use unions, right? I will get into more about structs a little bit later, but let me first introduce you to unions, right? So we can simply use a union, and the only difference is that in struct, these values they have separate fields altogether, but in union they are put in a compact mode. That means that they uh, they refer to the same thing. Like for example, in this struct, I have a float real and float imaginary, right? But what about I don't want to use it like that. I want to have like other aliases for this name. So what I can do is I can define an union, okay, and that union is this. It's good. Like, so, and you can also define structs that have no names. Okay, you can just directly define it like this, and you can use it. So now what I can do is this is equivalent to like having a real and imaginary, and also being able to use the struct by the, like, as an ordinary array. So or I can call it data, for example. So the difference will be that I can write this like complex C1, and then I can say that C1, let's make this a small c, and I can say that C1 dot real equals to this, C1 dot imaginary equals to this, and I can also declare like I can write a function, like I can call it void print, which takes a struct which is of type complex. So I just said complex because you just treat it as ordinary variable, nothing else. So it just puts the floating point numbers, the real and the imaginary. And also, like, because the imaginary number can be negative or positive, so we can also check that. Like, if see that imaginary is less than is greater than 0, then we will probably do this. Otherwise, we will probably like just say that printf this. Okay, and this minus sign need not be there because a minus sign will automatically be there for the imaginary, right? I can just remove this minus from here. Right. So this function takes a struct and prints it. So I can say that like inside your struct, if you don't provide any name, right? So it will be directly accessible. So like C1 dot real and C1 dot imaginary will be accessible the ordinary way. So I can say that for example complex C2, and I can say that C2 dot data 0 is 3 and C2 dot data 1 is -4, for example. Point is 0f, and then I can just say that okay, I'm done with it, just print them. So print C1 and print C2. Okay, so now if I compile this program and it does not uh, have any syntax error like this, I can get that's the same thing. Like, this is my real number, this is the second wave, defining things, right? So what's the the difference between a union and struct is that a struct is a collection of data which are situated in different memory locations. Like the first 4 bytes is for this real, the second 4 bytes is for this real, like this float, and second 4 bytes for this float. But in case of union, what you get is that you have multiple datas inside that union, but all of them will refer to the same memory. So you have to also ensure that the all the 4 datas will like all the datas will be of same size that you are providing. Okay, one good example of using union is this. Okay, where you need like multiple ways to access your data, right? Uh, uh, your unions are useful at some places, but like in most of the cases, you will probably don't need them. One other good example is like when you are trying to have different names for the same variable. For example, I have a struct called vec3, which defines a three-dimensional vector. So what I would typically have is I will have a union which can have like float xyz to define that as like I can access them by struct dot x like vec3 whatever I define dot x dot y dot z, or I can access by data, or I can even say that okay, I want to access it like this, like struct, it will be float r, float G, and float V. So I can also like treat that as a color. So union is just to use a data, whatever members are defined in the data in the union has to be of same size, and they can refer to like same memory, but they can have different layouts and different types of data. Another example I can give you is that I can have a struct, let's say uh, int 64, which is a 64-bit integer, and so it can have like the direct 64. Okay, so like it is a number, and also I can say that I can split that number into two halves. One is the lower half of the data, and what is the one is the higher half of the data. Because n64 takes 8 bytes, and this also like 4 bytes plus 4 bytes equals to 8 bytes, right? So you have to have the same thing, and you can nest how much you want, but typically people don't like to nest too much. It makes things difficult for them. But also like you can have like structs inside of structs like this, like if you give no name, then it will be like accessible by dot. But let's say I have a struct called user, for example. Let's remove all this stuff. So let's say I have a struct called user, and a user that has another struct, and s will be small. Okay, and always put the semicolon here, and I can say that like the user has a name. Okay, and the user has another complex data called its address, his address. So I can say struct address. Like I can define this like this: address, address. Okay, and if I like it like this, the address will have like treat like I can just have constant size like 20 and so on, and then like city and like state and so on. Okay, and I can simply access them like this, and then I can have like a character phone number that has 14 places, and then I can just access it like this. For example, I have a user user, and then I can say that user dot name is equals to, let's say, this, and then user dot address the street equals to this, user dot address the city equals to this, and so on, right? And then what I can do is I can write a print function. So void print, which takes a user, and because this is a huge data, it's going to be copied. What I would probably like to do is I will put an person here to ensure that I'm not copying the data once again the entire time, but just using the original data. And also like in print, I would like I don't like to modify this data, so I just specify that this is a constant. So you can read the data, but you will not be able to modify the data in this function. So and also like it will not copy the data. But this is a simple example, so you can just go user, and then I can just do it like this, right? And whenever you're printing a string, you just use percentile s. Okay. So now that we have that, we can like print the user, and we can like try to compile this. It throws a bunch of error, like it's not assignable, obviously. So you can just assign string like this for some reason. But what you can use is you can include a library that can help you work with strings, that is called C string. And what you can do is instead of like right, if they were numbers that you can directly assign them, but like it was my bad doing that. What you can do is you can just say strcpy cpy, and I want to copy these things, so it just copies one string into another, right? So it's the same thing. And like if I now run this, it compiles perfectly, and then I can execute this and I get the data of the user, right? So you can even work on this even further. We can say that okay, just like this, I can create another function, void create user, which takes like a string. And by the way, you give a function string as like this, just how I said that it's just like in the previous video what I said is that you don't want to modify this, you just want to take that value. So I am using const, and because like arrays are pointers are same, I just say character stars. So const character stars are basically C strings that you don't want to modify. And with that we can like replace all these HTTP calls here, and we can just simply say that I have a user, and then create user will create the user, and then print the user. I don't want to print the user, I just want to return the user, right? And so this function, it will be of type user because it's returning a user. We will talk about functions later because functions has so many things to talk about. Just like we thought that everything is simple, but then they have a lot of use cases that we have to cover. So we can create a new user like this, like user, and then it creates a new user, right? And we can even use like one liner, like user equals to create user, this, right? And then we can print the user. So let's just try to do that. uh, First we compile it, it compiles and runs and produces the same output. So now that we have this thing, let's talk about the difference between like the more things that C++ adds to the structs that C doesn't provide. Along with like the first of all, I would like to see the size of a user. So what I would probably do is I will sorry you I will say that okay, mm, what is the size of the user that I'm interested in, very much interested in. So I can say that printf percentile d, and that's the same size of user. Yeah, and there is one extra quotation. So if I run this, it says that I have made a spelling mistake for printf. So just quickly put a t here, fix that, right? And yeah, we can compile this and we can run this, and you can see that it takes 89 bytes in this case. Okay. And as long as you don't use something like align as or like slightly compact data, it's going to add some padding or not, depending on its own fantasy. Okay. So you can't do anything. thing about it unless you like use spam with it some with some more words. Like C++ is very word specific, and that's where like C++ gets confused. Like today I showed you constant. There are like a lot of other keywords that you can like specify to give us exactly specify like how you want the things to be done. Okay, but we will get to them those. Now we are doing simply. But the difference between struct in C and C++ is that a struct can always also have like functions there inside. Okay, so I can just put it here and it will work. Okay, uh, let's just move this one block. So you can also contain the like struct itself having the function, and to access something that is inside the struct, you just you don't need to like put user dot. That is the biggest difference. Okay, you can just simply like use the fields as they are, right? So I can just do this and it will work just fine, right? And so you can check this. We don't need to like use the print statement anymore. We can just say user dot print, right? And if I do that, it compiles fine and it produces the same output. We can go even further and we can say that okay, just create user thing. There are two ways. One way is that you can just say that okay, this is also my struct, and I don't want to like I can just copy all those things that has been provided to me and like this, and it will be a little bit confusing because name is equals to name and so on. So the better way of doing that, what I typically do is like I put an underscore in front of all the members of this struct so that I can easily access them. Okay, that is one way of doing it. Okay, like, I just that way I just make that okay. This is there, and it makes me have like different naming conventions like underscore address dot underscore states. This is one way of doing things. The other way is because that this name is here. This name is going to be like get the first priority, then this one. So you can there is a built-in variable in every structs, or later you will know about classes, is that it's this. The keyword is called this, and this refers to the same thing, but this is a pointer. So whenever you are using pointers, you need to use ampersand arrows. Okay, so if you're using like for example this address is a pointer, then you will probably do this. Okay, so for this we will do this, like this name is this address, but address is not pointer, it's just a memory variable, so we use dot. This address is this, and this address dot state is this, and this phone number is this. Okay, so this is how you can access the variables inside the struct via using this operator. This means that this current struct that I am using, right? And whatever that instance is, we will talk about instance in a separate video. But these things that they're not supported in C. You cannot put like functions inside struct in C. But in C++ you can do, because in C++ structs and classes are same. We'll talk about classes in a separate video. But for now, just know that structs and classes are same. The only difference is that everything that is inside a struct is a public. Okay, so they can be accessed without any issue from anywhere. So that is it. Another way of doing it is like we can bring our complex struct back complex, for example, complex like this, and it can have like int float real and float imaginary. And for example, if I for this complex, if I want to like dynamically allocate in the heap, So it's just a bunch of pointers, just like here this is a pointer. So in case of pointers, you don't use dot, but you use arrow. There is a difference. So I'll just show you. Let's keep the users out of the scope for a second. I'm just commenting them. I can just say that okay, I have this good complex class, and I want to like dynamically allocate some complex. So I can just say complex pointer c equals to like 20 complex numbers, for example. So new complex 20. Okay, so I have 20 complex number in this way. And then if you need to like access them, we'll say that C1, like obviously this is C, okay, complex CS for complexes. So CS is 0, but because this is a pointer, uh, like this is an array now, so you can do it like this: C10 dot real, C10 dot imaginary. But let's say I have only one complex C. This is a pointer. Whenever you are using a pointer, then you can't do this like C dot real and C dot imaginary because it's a pointer. Just like I used with this, you just use arrows here. So if the data type is of pointer and you want to access its members, whatever inside like user defined data type is called its members. Okay, so these are member functions, these are member properties, or whatever you can call it. But if you're using a pointer, then you will probably use arrow operator like here, and this is a pointer pointing to the current instance of the uh, data. What a instance means is that like I have a C complex, then I have, let's say I have another complex C1. Okay, so in this case, like if I have, so this for C will refer to the datas that are inside this particular C, and this for C1 will refer to the datas that are inside C1. Okay, so that's what these means, and these are, you can think of them as prototypes, and these are called their instances because these are the blueprints and these are the final products. Okay, this is the blueprint. Okay, it doesn't do anything, it just says that it just defines some behaviors, just how we define a function, and this is equivalent to calling a function, getting some actual thing that exists in the memory. So we call this as instances. Okay, so that being done, and also understanding like how these things work, we can just delete all these things and focus on that current task here. So we can remove all these things, and we can say that okay, I'm no longer interested in returning it because why should I return? I am the thing. It sounds very good, and also like I will not use something like create user, but just create. Okay, because I want to create. So the only difference that will be here is that I have this user, right? And I can call like user dot create and then user dot print, and suddenly my code becomes a lot more cleaner. That's the one of the reasons why structs, class, and these things are used, and like it becomes very beautiful, right? You have like clean code. One of the things that I don't like, it's saying that in the line 15 and line 21 there is some error, so you just fix those things. So in line 15 here, it says there is an error. Why there is an error? Like sometimes I become dumb and I don't get like, oh yeah, so the error is that like this is a pointer now, so I probably need to like dereference it like this. Okay, and so what I prefer to do altogether, that I told you, is just use underscores. They make your life too much simple to not use them. Okay, like, what goes like, and also like they clearly like specify that okay, this is a member of the struct and not something else. So I probably like to do it this way. Okay, this is my choice. Your choice is up to it. Some people like aim underscore and like that. Like how you want to name your variables is up to you. But you should try to be consistent so that other peoples who are trying to read or modify your code don't get too much confused. Like you can write very confusing codes and also like very performant codes, but sometimes you just like you don't go that into that rabbit hole. The only reason being that you want to be a good human being and you want to support others and you want to be in the group and not outside the group of the people and like an outcast of the society of programming. Okay, like like the next things that I will show you, it's probably because you need to know them, but all of them are slow. Like polymorphism and stuff like that. When I will show you, they're actually very slow. Mm. So I don't know if it has like and also like I forgot to give the type. So why did it? Actually, this dot name was fine. This dot name was fine. There was no problem because this dot name at the end of the day just referred to that variable. So it was fine. But still, I like to do it this way. Okay, that was fine. The error was being thrown because I didn't give the type. Okay, and I am a human being. I make mistakes. So and like all programmer does. I don't know if others do. You can see that now that the code is much more cleaner, and I can get all the outputs that I want. And to just prove you my point, I can just remove all these underscores and put this arrow. It will be equivalent, but like you can try it yourself, right? Whether I'm right or wrong. What I want to show you is another thing that is called a constructor. And a constructor is something that is run whenever the like every time it's created. So you can just specify that this is and to create a constructor, it's basically a function with no type and has the same name as the struct, right? So user, and here is the user, right? And the benefit of doing that is now you can do it like this in one line. Like I'm declaring a new user, which is this, right? And now if I let's say compile this and if I run this, you can see that it gets the job done. Okay. And here, what comes next is that structs are nothing but like, for example, if I want to use, let's talk about now, like I don't know, like I knew, but I forgot the term. But there are like inheritance, polymorphism, and it's called abstraction. So like you can see that this whole thing has abstracted the user. I don't need to know specific about how the print is done. Okay, it might lay anywhere. As long as I know that the print function does the job, I can just use it. But here is the thing that like when you are going in this way, it's called OPP. Still now, whatever we were doing was functional programming, but now we are into object-oriented programming, right? Because these are called objects. Okay, these instances are also called objects. People just keep they just like giving a lot of names to just confuse themselves and others and feel to be smart about it. But that's it. So what I want to probably do is I want to say that these values I don't want them to be accessible from outside. So what I can say is I can declare them as private. So you can use them inside the struct. All the functions that are inside the struct, they will be able to access these private values. But outside the struct, you will not be able to use these private members anymore. Except these are declared as public, so you can only use the public ones. Like these two functions you can use from outside, but these things you can't use from outside, right? And also like the functions that you add, they don't add to the total memory that struct or class probably takes. So you can feel free to spam them here. Okay, I would like if you're using C++ and you're using functional programming, like come on dude, you can just put them here. And like this particular thing is zero cost, so you can just get away with it. Okay, if someone doesn't catch you and like beat you like a dog for not going by their standards. So that being said, I can do this. You can see that the behavior itself doesn't change. The program compiles and the program runs. But as soon as I try to like access the name from outside, like if I want to say user dot name, just I want to like for example printf percentile d not n %d, but percentile d, the user dot name underscore name in this case, it will give me a huge error or warning. I don't know whatever it will do. Yeah, but it show you error, and that error was the forget about the printf. The error was that this cannot be accessed because this is a private member. Okay, so what that allows you is that you created a beautiful struct that does some things, but you don't want the others to get into that struct and mess up with things that are there inside. You just want to like close the access from outside. So that's what where private comes. So by default all members of the struct is public. So if I just remove public, put private from here and put private here, I can access the name from outside. Okay, and this will be percentile s. Okay, so I can even access the name from outside now. As you can see, it compiles and it runs. Okay, so I have John Doe accessed here, the name outside, but I can't access any other members. Okay. For example, if I want to like access the phone number, for example, okay, user dot underscore CWPHO phone, right? I can't do that because the phone number is declared as private. Okay. So that's the difference between public and private. And this thing, the concept that it introduces in like object-oriented programming is called encapsulation. Okay. These things, this allows you to do encapsulation. I don't know the spelling. This might be the spelling. It might not be the spelling. I don't know. But this is what encapsulation is. Okay. And the only difference is that between structs and classes in C++ is that structs have all the members by default stated as public. Class, on the other hand, just replaces this struct keyword with class, and it has all the members as private, right? So although in struct this was valid, in class will throw me all the errors, right? So the fix is simple. What we did earlier, uh, let me open the file, is that I want to be able to access these functions outside. I will just say these are public, right? And also, like I have told you that this is a constructor as well as a class as destructor. Like if you have some dynamically allocated memory, you would like when the object goes out of the scope, you might probably want to remove that dynamically allocated memory. For example, I might have something like int star id, okay, which is dynamically allocated. Like somehow I thought that it would be an like cool idea of doing that, and I will just use a random, so I included CST and I can just say that ID is equals to a new int. I don't want to type this long for this particular silly thing. That's it. So ID is a new int, and the value is nothing but a random number. Okay, modulus like for example 10,000. Okay. So this ID, because this is a pointer, it will not be deallocated by itself automatic. So what I would probably do in that case is I will just provide a tilde sign in front of it, and before I go out of my scope, I will delete it. Okay. So I can even say that here printf uh, constructor called, and I can say here printf destructor called. And destructor, you don't call it by yourself. Whenever the variable goes outside the scope, it's automatically called by itself. Okay, so that's how you keep things clean and like not getting out of the memory, causing memory leaks and stuff like that. It's as simple as this. All right. So now that if we uh, run this, um, for that I need to first compile this. So CL, it throws a lot of errors saying that username cannot be accessed private, etc. etc. Oh, I forgot to like remove the last two lines. So let's just quickly do that. If I find that this is from the last video, vim use cpp, and the issue was these two lines because these were private and I tried to access them from outside. So now that we are getting secured, but also we are falling into a like hellhole, right? So that's the life. But as you can see, the constructor was called and the destructor was called automatically, although we didn't call it. Okay. So this is how the magics start to happen. And this is how you typically define a class. Okay. In case of struct, the default behavior is being private, public. In class, the default behavior is being private. Now I can go on a lot of things. I can define like I can talk about a lot of things, but I would probably show them for some other videos because like classes they provide you four functionalities, which are being like one is your abstraction, which means that I can do this kind of things and hide a lot of functionalities like this inside the class itself. So it's just hiding the details. Then it gives you like encapsulations. The data and methods are bundled together, and also like the data hiding. Like some data I want to show, I have some data method I don't want to hide. In inheritance, which is nothing but like having like a parent-child relationship between different classes and objects, so that I don't need to write things again and again and again. And then polymorphism, like having same function do different tasks for different types of inheritances, and this is something bad. Okay, this is slow, and like I don't like this. Like don't use for high performance code. Okay, so we will talk about them in a video dedicated to classes. But that's basically at the user defined data types. I hope that this video was helpful, and this video opened a lot of like ways in front of you. Now you can probably create a linked list of your own and like go crazy about it. You can like do all the things like except using some fancy things to like make things be minimal. As long as you know that like these libraries provide these functions and these stuffs, you can go crazy. Like these are the basic things that you need to know about like coding in C or C++. These things are particularly of C++. Okay, C doesn't have any like class and those things. Okay, keep it in mind. Okay, and in C structs, you can just define methods inside. This is in C++. This is where C++ it becomes a superset of C. Okay, not exactly. There are some like things that are like specific to C that are not in C++, like how like structs are used and so on. Also like some generic types, but this is it. Okay, so hope you have enjoyed this session. Uh, I hope that makes any sense to you and makes your life easy. So thank you for watching this video and bye. See you next time.